Oh, can everybody hear? Am I audible to you?
Yes, sir, you are audible.
Okay. Can all of you see the screen, please? Can all of you see the screen?
Yes, sir.
Okay. Okay.
Yes, sir.
Right. Shall I continue or shall I hold on? Because only 22 participants are there. That means
No,
barring
we
3 or 4.
should continue, sir.
Okay.
Actually, time has happened for the second session. We should
Okay.
actually go with the
Right.
time.
Okay, no problem. No problem. Good afternoon and also welcome to the second session. This particular session covers innovations and challenges in smart metering system solutions. So as we proceed, probably you will understand more about the smart metering system and also system solutions. So how this architecture of smart meter is conceived, how smart metering is used as a total holistic system solution is the essence of the presentation. So this presentation probably will also cross around 1 hour or maybe slightly more than that actually. And we will have questions and answers at the end. My request is all of you please mute your radio so that others are not disturbed. When you join silently and you can see the presentation. At the end, we can ask questions and answers. That is the arrangement for the day. If it is okay, then we will continue. If anybody is joining, please join silently. Right. Thank you. So we will start our afternoon presentation with a beautiful note from Bharat Ratna, Dr. Abdul Kalam, who has contributed quite a lot to the educational system of Indian culture. So learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. Knowledge makes you great. I think one of the best quotes. Normally I quote this everywhere. And I think with this probably we will continue so that we will get a lot of energy from this saying, which is traditionally being accepted all over the world. Okay. So anyhow, sorry, there is a phone call. Sorry for the disturbance. Okay. So we will continue with the presentation. In fact, smart meter technology, when we talk, we have to discuss, its FBD architecture. That is the functional block diagram approach for the architecture of the smart meter. Then we will understand, more about its implications, its working principle, its functions, and also its characteristics. To a certain extent, we will discuss, the design, and also we will see how the integration into a different combination of technology could be made by virtue of what we call as the structural method of arranging the whole thing into a system integrated challenging solution in the power domain. So we'll understand that. This is a typical smart meter. How you can identify that? By virtue of these signals. As you can see here, the Wi-Fi signal is mentioned on the nameplate of the meter. So if you look at the smart meter, other meters, this particular signal will not be there. That means the meter is capable of communicating on a bidirectional mechanism. That means that is, from you to the meter and meter to you. So that is what it happens. That is what, the main crux of this particular presentation. So we'll discuss more about it as we proceed further. Okay. What is smart metering? What is that actually? So smart metering is defined as SMART. S stands for specific. M stands for measurable. A stands for an attainable technological innovative thing. R is realistic on its platform. And T is on the time-based measurement. So that means to say SMART stands for the smart metering application. So it is nothing but an automatic reading, processing, and transmission of metering data. So possibility of bidirectional data communication in real time or with only a small time lag. Support of additional services and applications. Example, home automation, remote connection, remote disconnection of the power supply, and also remote update of meter firmware to enable the new services, new communication protocols, and also the smart meters are used mainly for the above purposes. That is what we have to understand more about its smart metering applications. So types of energy meters today. Okay, the electromechanical meters, we were using it for almost 120 years when Ferrari conceived this. Italian physicist conceived it almost 120 years ago. So this meter lived for nearly 120 years, and now the technology has become totally obsolete. And most of the meter manufacturers have stopped manufacturing these types of mechanical meters. But incidentally, in fact, even educational institutions have not changed over, from the present syllabus to teach.
Sorry to interrupt you, sir. You are not audible.
Not audible?
Right now you are audible. Couple of minutes ago you were not audible.
Oh, okay. Is it all right now?
Yeah, it's all right.
So types of energy meters. I think we are discussing that, in our mind. Probably we have to understand what are all the main types of energy meters. The electromechanical meters, which lived for almost 120 years since, the Italian physicist Ferrari conceived this induction type meter, which is being taught even today. But it has been totally outlived in its performance. It has definitely given standard performance to electricity boards, particularly for revenue collection, but it had limited sort of applications. The next generation meter was actually, in fact, even these meters are also getting totally outdated. These are all hybrid versions. Hybrid versions means the mechanical registering mechanism, whatever is prevalent in the meter, is being utilized with electronics for measurement. Okay, so those meters are known as hybrid meters. So these meters are also known as 2G meters, because the mechanical meter is known as 1G meter, first generation. The second generation is hybrid meter. The third generation meter is a combination of analog and digital meter. That means, some circuitry is analog and some circuitry is digital. Okay, multiplication, etc. is done on the digital platform. Okay, so the fourth generation meter is actually the smart meter, which we call 4G, and we are going to concentrate on this particular meter, as this is the technology, as this is the meter of the future. So we will see what it does. We will also see how it works. We will also see how the design is done. We will also see how the integration is done. And also we will explore the system solution with different methodology of communication and different methodology of adaptation. So we will see one by one. So introduction of watt hour meter performance, mainly an ideal watt hour meter. What is watt hour? Watt hour is nothing but your total energy. Okay, if you express in kilowatt hour, you are paying the kilowatt hour charges today. Okay, if it is megawatt hours, it is actually higher than that which is used normally for the large power energy consumers. Okay, this is what the present need. The requisites of an ideal whatever meters are: number one, accurate registration under all reasonable load condition. Reasonable load is what? A load which is almost linear, because it is the prerogative of the user, that is myself, yourself, etc., to make sure that you use the linear load. Y is equal to mx plus c. It should follow this equation. But as you see today, most of the loads are non-linear loads. That means we are only responsible for creating what is known as harmonics. So these nonlinear loads will have its own entity in the electrical engineering today to make it linear. What effort we have to put, etc., is one of the challenges which remains to be solved actually. Anyhow, although it is out of scope of the subject of the day, we have to consider this in the what is known as the power quality management structure. How the power is managed, how the quality of power is managed. As I told you, the distortion factor is one of the major things that is contributing for the power harmonics introduction in the power system. Okay, sustained accuracy for several years, that means to say it should maintain accuracy over a period of time. So attention and of minimum attention and expenditure, the least attention, that means to say the meter need not be attended to for its maintenance, and also it should be possibly be inexpensive from the point of introduction to the new technology systems. And it shall develop low internal loss. We will talk more about it as we proceed, because low internal loss means what? The loss the meter consumes, the power the meter consumes. The meter is connected in the single phase or three-phase mode. The meter is energized for all the 24 hours, 24/7, and it will be consuming the power whether you tap the load or don't tap the load. So this loss is going to be the internal loss to the system. So we will see how we can minimize it, how the smart meter is answering these things. We will see as we proceed further. So independent of normal variation due to temperature, due to voltage, due to power factor, due to waveform, due to frequency, due to external magnetic field, due to the vibration, mechanical vibration, and also due to the other factors, which is influencing, like, the support, etc. Support in the sense how the meter is being installed. The meter shall start on a very, very light load. What load, etc., we will explore that as we proceed. And to the specification limit, we will talk. Capacity and reasonable accuracy on higher loads, overloads. How the meter is operating at overload. What is overload? Overload in the sense, the meter is designated as, for example, 10-100 amps. 10-100 amps is the designation of the meter on the nameplate. What does 10 imply? 10 implies it is basic current, the current which is used as the basis for the standard. 100 is the maximum continuous current the meter can carry without distorting the total load characteristics. You just bear that in mind. Okay, that means to say these meters are said to be 1000% overloadable meter, because 10 to 100, that is 10 times. These meters are known as 1000% overloadable meters. Okay, from the practical physical standpoint, the meter will be light in weight, compact in dimension, rugged in construction, easy to install, easy to test, and easy to adjust. You can't adjust electronic meter. All adjustments are provided in the mechanical meters, like the brake magnet adjustment, the inductive load adjustment, and also the light load adjustment. Okay, and torque balancing adjustment. These are all the adjustments provided, because more the adjustments, the meter becomes more sort of fragile. It will not answer the question, whatever you want to make the meter more stable. It is not possible from the point of what? From the point of adjustments. If more adjustments means naturally you will be maneuvering the meter, and meter becomes unstable. So electronic meter need not be adjusted. It is a factory set adjustment. It is a laser trimmed arrangement where the whole meter works satisfactorily over the complete load characteristics domain. That means from 10 amps to 100 amps, very accurately it will function. So this is the introduction on the requirement of the meters. Okay. Other requirements are, for example, the accuracy. That is, it shall be less than 1% measurement accuracy. What is 1%? Plus or minus 1%. That means if you draw a line, a curve between the percentage load and percentage error, you will get 1% as the window we call. This is known as meter dynamic characteristic feature. From the manufacturing point of view and also from the user point of view, the meter shall be cost effective. And also from the manufacturing point of view, ease of manufacturing, simplicity in calibration, and simplicity in not calibration in the sense what? Trimming all the adjustments to make sure that the meter maintains the set accuracy, reliability, consistency of functionalities over a period of time, stability of performance. These are all certain things, which will have the impact on the application. This is the smart meter block diagram. I told you the functional diagram, the functional diagram of that meter is looking like this. It comprises of two boards. One is the metrology board. The metrology board is a board which does the metrology calculations. That means the measurement calculations. Okay, I will tell you what calculations, etc. The communication board will provide the necessary home area network communication, neighbor area network communication on a microprocessor based control system. So it has a power supply on both modules, and then the meter is working on this particular principle. So one is the metrology board, other is the communication board. We will see more about that. All these, wherever I have taken, I have sourced it from the Smart Meters Wireless Safety Summit. In fact, I told you in the morning that most of these presentations, why most 100%, we have taken from LinkedIn, and all these things have been moduled in such a fashion that it can answer your requirement. So better you follow LinkedIn and also ascertain that you will get updated information. Not only what is happening here and what is happening elsewhere also, you can coordinate with that and then make sure that your digital domain knowledge is improved professionally. What are all the benefits of this smart meter? Because we have to see smart meters in future, particularly main benefits. In fact, the device and load control. This is a very, very important thing actually. Controlling load. Controlling load means what? It will switch off unnecessary loads. Through what? Through internal relay. I will tell you more about it. It has a bipolar electrical relay that will switch off and switch on the load whenever it is required, whenever it is not required. This particular thing is an intelligent mechanism with which the meter is working through the communication, like maybe hand. In the hand you have the RF based radio frequency may be a Zigbee communication, or it may be a Wi-Fi communication. We will talk more about it, but anyhow, communication engineering itself is one of the chapters in smart meters and smart grids. So we deal with particularly what type of communication is suitable specifically for these applications. Next is the energy auditing it does. For example, the distribution transformer, how many houses are fed and how many consumers are there. The sigma of that house meters is equal to one distribution transformer meter which caters to that. The difference is error, and that difference was more during mechanical meters, were slightly less during analog meters, was slightly less during hybrid meters. But today with the smart meter introduction, take the international experience, like in Americans, Europeans, they have installed in millions, whereas India is yet to do this particular exercise in bulk. You know how many meters are there in India? Like Indian population. In India we have 250 million meters. All these 250 million meters need to be made smart, unless you engineers work hard on this professional platform, because you can envisage the business. It's a huge business, and also the not only business opportunity, job opportunity. As you become electrical engineer, you can definitely get into a good job with an electrical meter manufacturer, because openings are plenty today in this particular arena. Okay. And then most important thing is outage management system. We call this as OMS. So this is also done on the consumer engagement via in-home display. We will discuss more about it. We will spend more time. In fact, don't think that you know everything about meters. Please listen to me. Your knowledge in meter as this presentation goes on, it may be very small. But when you just cross the presentation, probably you will be in a position to understand the latest things, the latest technology, the latest system integration, etc. So that you become really a professional, in the field of smart metering, in the field of smart grid mechanism. That is our intention. So a smart meter is a new kind of electricity meter, so that can totally digitally send meter readings to your energy supplier. Who is energy supplier? One who supplies the energy to you. Okay, that means he is the one particular agency which is responsible for 24/7 supply with this particular metering philosophy. So this can ensure accurate energy bill. Smart meters also come with monitors, digital monitors. You can better understand your energy usage also. And there is one equipment which is known as the in-home display system, IHD. I will talk to you more about it, and you will also know more about it. Anyhow, yeah.
Excuse me, sir. You're not audible, sir. Hello. Can you listen me, sir? You're not audible. Hello, sir.
Dear participant, there is some internet problem, so please wait for 5 minutes.
Dear friends, dear students, there is some technical issue. Our experts will be joining back in a very short duration time. So be with us.
Hello. Hello.
Yes, sir.
Can you? In fact, I cannot share the screen. It is coming. The host has disabled participant screen sharing.
Okay.
Can you make the screen sharing?
Yes, yes, yes. Now you can, sir.
No, okay. Okay. Can you see the screen now? Hello?
Take notes. Yes, sir.
Can you see the screen?
Yeah, yeah. Your screen is visible, sir.
Visible? Okay, 1 minute.
Yes, sir.
1 minute. Can you see?
Yeah, it's
Okay.
visible, sir.
Okay, okay. Okay. Sorry for this trouble.
No issue, sir.
Okay. So right, we were discussing about, can all of you see? Can all of you listen? Yeah.
Yes, sir.
Okay, fine. So I think the patch can be removed by you. I think you have to remove there is a patch coming on the screen. Okay.
No, it's okay, sir.
This patch, there is a patch actually which is coming on the screen. No problem, huh? But you have to remove that patch actually.
Okay.
Okay. Which is obstructing probably others also. Right?
So from our side, it's no patch on the screen. It's
On
clear
screen, in
screen.
my screen, it's anyhow, no problem. I will just continue with the presentation. Right?
Yeah.
So we were discussing about, the electronic device, particularly the smart meter, how it works actually. A smart meter, the main definition is, it is a device that records the consumption of electrical energy in intervals, as I told you, 1 hour, 30 minutes, 15 minutes, and even in the international scenario, it has been made 5 minutes actually to get large amount of data. And this large amount of data leads to one particular technology that is nothing but your big data analytics. So big data analytics is coming here to mainly focus on the large data transfer and large data analysis. In fact, the data is in terms of terabytes actually. Okay, so this terabyte data is to be monitored and is to be established, validated, is to be cleaned, and is to be appraised for different applications. We will talk more about as we proceed further, because data analytics, data science is one of the offshoot of the smart grid technology today and smart metering technology today. So
Excuse me, sir.
pardon me?
On the screen, there is the front page of Zoom is actually visible. Are you sharing your slides?
Yeah, I am slating my slide. Yeah.
Slide
is not
but
being
your system
seen?
is actually no, sir. Slide is not visible. Zoom page is visible.
Zoom page is slide is not visible.
No, slide is not visible. Huh?
1 minute, hold on. I will share the screen now. I will share it. Okay. Now can you see?
Yes, sir. Now
Can you
it's
see?
visible. Yeah,
Yeah,
now
yeah, it's visible, sir.
Okay, fine. So I was talking to you about, the smart meter, particular, how it works, in the communication technology domain. As I told you, the meter, it enables bidirectional communication between the meter and the central system. Central system is what? Your corporate office, which is responsible for your billing, which is responsible for not only billing, collection, and other energy management issues. Unlike home energy monitor, smart meters can gather data for remote reporting, such as advanced metering infrastructure, that is what we call AMI. We will talk more about AMI actually, because AMI is a total system solution, which is nothing but smart meter, but other combinations also. Okay, so as we talk, probably we will get into this particular mode. Smart meters, they use secure national communication network. We call it as DCC, data communication channel. Okay, to automatically and wirelessly send your actual consumed energy to the supplier. So this means households will no longer rely on estimated energy bills, and they have to provide their own regular readings or have meter readers come into their homes to read the meter. Not necessary. Meter reader will not come here. For example, you are paying your telephone charge. How you are paying your telephone charge? You are not seeing the meter. Meter is somewhere actually. Although a smart meter is in your premises, he will not come and take the reading, but you will know what is happening there actually. Through what? Not only through but by your vision, but also by what is known as in-home display, which I will talk to you. Okay, are you clear? So smart meters will also come with an in-home display. So this display gives you the household real-time usage pattern, including kilowatt hour use and cost. So we will see what it is. What are the main benefits of having a smart meter? Number one, accuracy in billing. In fact, that means estimation is not there. Second thing is understanding of your usage. That means how the pattern of usage is there. With a smart meter display, you can see direct impact your habits, your lifestyle, and your billing structure. This is particularly useful to prepayment meter customers. That means, prepayment means pay and use electricity. You pay in advance and use electricity. That is prepayment. Okay. But smart meter is having all these features. It may have prepayment feature also. We have credit card payment also. That means you can take the credit. Who can better track how their usage impacts their availability credit? By making your energy usage easier to understand, you can make smarter decisions to save energy, money, including more confident switching energy supplier. Suppose you are not satisfied with one supplier, you can always choose the other one. So it is a market thing actually. And you don't have to depend on one particular supplier today, because beneficiaries are plenty today. And they're all working, towards a particular simple goal, achieving the objective of smartness in the smart grid system, achieving the objective of smart metering capability to the consumer. So this is a main thing and main important thing actually. So it's a faster and easier energy switching, okay, and bringing energy system into the 21st century, where the future is smart and smart meters play a major role. It is innovative energy tariff using the data collected on when, how households are using energy, at what time he has used energy, at what time he has switched on high energy consumable things. Okay, suppliers can create more competitive time of use tariff with cheaper price for off-peak usage. So this facility is most important thing. There is a need actually in the international scenario that smart meter will increase your bill, energy bill. No, it is not. It is going to intelligently manage your total versatility of billing. Suppose the electricity board is having an option of, say for example, time of the day tariff, and you can pay less during off peak hours. So that is possible. It automatically takes care into that particular mode. So this is known as time of use structure billing mechanism. This is done automatically by enforcing the software mechanism logically built into the circuitry. So this is your morning coffee, and this is your indication how much electricity you have consumed and how much is the charge. Everything will be indicated to you on this particular mechanism. Smart meters measure how much gas, electricity you are using, as well as what is its cost and display. So this is a handy thing in an in-home display, IHD. This is supplied along with the meter. You may like it or not. You can keep it in your kitchen, bathroom, whatever, wherever it is, and you will monitor how much of water heating has cost you, how much of dishwasher has costed, how much of the AC. Mainly, the AC consumes huge power actually, as you know. How much is the LCD, the TV has has costed the energy to you. So they also send automatic meter readings to your energy supplier, at least not in once in a month, even once in 10 minutes also. So you will receive accurate, not estimated bill. So for more detail, you can click this link. Actually, you will get abundant information with regards to what smart meter will do. So I have taken those things, and made it into English so that you can understand the whole thing. On an in-home display, you will be able to clearly see how much energy you are using, how much energy was used in the last hour, whether your electricity use is high, whether the electricity use can be consummated with your own application, how much is the credit you have, what is the amount of credit is left with you, your debt balance, and if your credit is getting low, etc., will be displayed on a key platform. So this is how the in-home display will do the job. I will just take an example taken from LinkedIn in 2017. Actually, of course, maybe little slightly old, but still, it is accurate as far as the data is concerned. This is the number of mobile phones available in the world today. In fact, world mobile phones. China, how many mobile phones? India, how many mobile phones? And United States and Brazil. Okay. So we will take Indian example, and also we will see how many connections per 100 citizens are there. How many mobile phone connections? In world it is 97. In India it is 77.58. Although we are having one or two mobiles with us, the statistics is not meeting with the world requirement. Actually, particularly the United States has surpassed, but 103, 141, like that. Anyhow, we are not interested in that particular statistics. We are only interested in what is the actual consumption of this particular, what we call, the mobile phone charger, how much it will consume, whether it is billed or not. We will see in the next slide. Okay. Smart meter capability of converting small loads into a tariff. For example, each mobile phone charger consumes around 8 to 10 milliamps current at 240 volts with a power factor of 0.4 approximately, because it is mainly an SMP based circuitry, switch mode power supply with inductors and also with ringing converters. So naturally the power factor will be very small. Okay, if you convert into arithmetically, if you convert those things, 10 milliamps, 0.01 amps, 240 volts, that is the rated voltage of the country, okay, of the system. 0.4 is the power factor. So VI cos phi into that. VI cos phi is what? Power. Power into the number of installation. You have this number of installations here. Number of installations in number of phones what we have today, that is mobile phone chargers. Okay, and this is in watt hours. So watt hours convert into kilowatt hours divided by 1000, convert into megawatts divided by 1000. So we will get 922.1262 megawatts into, for example, into 2, 365 into 2. What is this 2 actually? 2 is you use every day 2 hours charging. Okay, you use every day 2 hours charging, and you take 2 years as the life of the charger. Normally you will throw away because these chargers are not at all definitely dependable. So how much energy is consumed? It consumes 13,46,348 megawatt hours, which is not registered in the present day meters. You just note this very, very important factor. You said you take just 50% of this. Okay, only 50% of this. Then how much? That will be approximately 6,73,174 megawatt hours is a loss, because this much of energy is definitely sufficient to light 3 big cities actually. So present meters will not convert this into tariff, and loss is to the exchequer. So smart meter does it. Even 3 to 5 milliamps will be read accurately, and the red current is actually converted into tariff. So this is the main thing, which you should understand. So India's per capita power consumption is among the lowest in the world. The per capita electricity consumption reaches 1010, that is 1010 kilowatt hours in June 2020. This is from the Central Electricity Authority Bulletin. So with this advantage, why smart meter, smart or advanced meters are different from standard kilowatt hour meters in many ways, particularly in two ways. First, the meter can measure and record both cumulative usage and highest demand for time intervals as small as 15 minutes, even less than that actually. Secondly, the meter can remotely communicate with a utility meter reading system either wirelessly, by telephone, or power line, or by Ethernet, or any other mechanism with which the communication is embedded into the system technology. Although the interval meters have been in place for many years, it is the total combination of holistic time of use measurement and communication in a smart meter that gives utilities advanced program and billing options for more customer services. So this is what it is. Smart meters do not save energy, people do it. Their sole purpose is to change the planning and bring an awareness. It is hoped that the consumers will save energy through increased awareness of how much they use, and that estimated bill will be eliminated. So this is the main crux of it actually. So the smart meter is usually an electrical meter that records the consumption of electrical energy in intervals of half an hour or even less and communicates that information at least daily or even less than that back to the corporate for monitoring and billing purposes. Okay, smart meters enable a bidirectional communication between the meter and the central system. Unlike home energy monitors, smart meters can gather data for remote reporting. What is the function of a smart meter? The main function of the smart meter is it collects the data, it communicates the system, it analyzes the data, and it provides a decision. So this is how the whole thing is done on a hierarchical transformation. So these are all the main smart meter functions. This is how the home energy we call IHD, or we call home energy information display, HEID, or even IHD we call, whatever it is. So this will give you the information about the monitoring of energy. What is the rate of energy at the time? What is the cost of energy? What is the cost during the month? What is the estimated bill? How many days are left in the cycle? And you can also, there will be a short monitoring of energy. You can click this, you will get the monitor. You click this, you will get my energy history. You click this, you will get energy manager. And you click here, you will get energy message center. It will give you various information. Okay, this is like the stock market, as I told you, and the present information it is available. So this will be kept either in your kitchen or bathroom, making sure that how much of energy you can monitor. Even you can find out where exactly the consumption pattern is more. Not only in the domestic installation, as you know, the domestic installation contribution to the power sector is very less, but the contribution from the industry sector is more. So this is more useful in the industry sector as a energy management tool. So that's what I'm telling you. So very important. So what is smart grid smart meters actually? Smart meter, as I told you, is a digital Wi-Fi, that is wirelessly fidelity enabled power meters that enable communication between the appliances in your home, business, or power provider. So you understand this very much, very important actually. So this provides you and your utility company with a total visibility of your energy usage and control over appliances as well. So smart grid vision has three primary parts. One is establishing the new communication and digital sensing philosophy and digital metering philosophy. The third is interfacing between the meter and the system and the customer through in-home technologies. So this is what it is. What is smart appliance? As I told you, I was talking to you in the morning. Smart appliance is an appliance which can communicate with a smart meter. For example, I am using the laptop. The laptop consumption is monitored, by the meter. On the heels of the smart meter come the deployment of smart appliance. It will have a small single chip actually. The chip can communicate with the meter. And also the load can be switched on or off depending upon the whatever the text you want. So this will affect all of us. Your household appliances will be equipped with chips that will allow your appliances to communicate with the smart meter. And if you buy into the automated plan, then the utility company will be able to control your usage if it wants or needs. Automated plan means a plan with smart communication. The plan is the plan is to penalize those who do not buy into the automated system by charging them with a flat rate or a higher rate. So this is what it is. That means to say, essentially, all the equipment, whatever you are going to buy in future, will have to have a communication modem system with that. With that, it is possible for you to intertwine between the meter and your load and make the system an energy efficient system application. So that is what it is mainly. Okay. Now there are two things. What is aggregate data and what is granular data? Aggregate data is a data which is read monthly by the meter reader. When the meter reader comes, he visits the house with a digital assistant and records your electrical usage, and he will note down the data. The type data is nothing but aggregated, note on the reading. Okay. So there were really no privacy issues, and the electric company was considered the owner of that information. Now, the utilities can detect the occupancy when you are in home, or whether you are away from the home, when you are sleeping, when you are awake, and when what appliances you are running, etc., can easily be seen with the modern metering system. So the data what you get for every 15 minutes or 10 minutes or 1 hour, whatever it is, this data is known as granular data. The granular data can be used to track your whereabouts, your habits, etc. So this is what the smart meter does. So aggregate data and also the granular data plays a major role. In fact, granular smart meter data, energy usage from time to time, the data access and privacy issues. So here is a table. Usage in kilowatts versus the time. For example, 12 a.m. to 12 a.m. next day, 24-hour cycle. For example, it is a sleeping mode we call. And suddenly at 6 a.m., you are starting your toaster, switching on your TV and all other appliances. Up to 8 o'clock, and from 10 o'clock, once again, sleeping mode, and 6 p.m. and sleeping mode in the sense, not large loads are switched on. And you go, there's a spike actually at 6 p.m. because you will be switching on all other appliances. Okay, so this is how, what we call the energy curve for the particular system is also transferred, into the transmission system, into the system where, the smart grid or smart meter will accumulate for or will account for. So this is what it is. What is a valuable data? The entities that may seek personal customer information, that includes, energy companies seeking to improve service, sell information, profit, third-party marketers, law enforcement agencies investigating, the possible criminal acts, frauds, okay, insurance companies seeking to identify unhealthy behavior in order to adjust rates, criminals attempting to perpetrate illegal acts. That means, illegal acts is done actually. Researchers looking into create new energy related studies. All these things can be obtained as valuable data from smart meter. The right hand side picture is a typical international smart meter with various features. Okay, time based tariff. That means, it is a multi-tariff. Multi-tariff in the sense, as you consume during time, this will be elapsed. Consumption statement to subscriber and corporation. Net metering. Net metering is what? Net metering is a philosophy which is used in the solar panels. When you are importing power from the solar, and when you are exporting the power back to the grid, the realization, the net energy consumption between what you have exported and what you have imported is net metering. In fact, there is a subject, it's a subject by itself, and this particular smart meter is having the feature of net metering. Okay, so notice of current outage and restoration of the current, electricity current disconnection, reconnection, load determination, monitoring electricity and current quality, quality of power. So detection of tampering, detection of theft, detection of fraud, if any, can be done actually. Suppose you touch the meter. So suppose you open the meter cover. There is a message to the register mobile stating that meter tampered, attend. So this particular philosophy is one of the best things available so that you cannot do anything in the meter as it stands today. So meter sends alert to meter data management system, which in turn sends alerts to the system operator. So alert appears on the meter screen and mobile app. Okay. So this is what it is. This is how we know the meter has traveled. Electromechanical meter, as I told you in the beginning. Hybrid meter also we discussed actually with electronic registering mechanism. Next, we move to the development of what is known as electronic meter, where we have the availability based tariff like ABT, like the TOD, time of the day, TOU, time of the use, and also we used certain mechanism for load survey, etc. Finally, the movement is towards smart meter, where the interval metering, OMS, prepayment option, in-home display, remote connection, remote disconnection, peak load management, demand side management, power quality, power management. All these things are possible in one go. How we have traveled from this meter to the final meter. How this is designed? Smart static energy meter design. How it is designed? You have the V transducer, small sample from V, sample voltage, sample current proportional to the voltage and current to be metered is fed to a multiplier. Multiplier does the multiplication. Different technologies are there. Time division multiplier. So many things are there. I don't think I should discuss that because there is a subject by itself. Next, the multiplied voltage and current will give you power at an angle theta. So power factor is also there if it is AC. Okay, fine. Then what happens? Then finally it goes to an integrator which integrates 0 to T, VIDT. So that is energy. So this is done by different communications, different methodologies. So this is how a smart meter is designed. So we will see in general how this is done. Main blocks of smart metering system. One is the voltage and current sensing block, signal conditioning block, and phase compensation network, which compensates for phase angle between current and voltage. Analog to digital conversion, that is done to A to D. These things are done with a DSP, digital signal processors. There's a multiplier actually. There may be an adder which adds this voltage to frequency converter, which converts the voltage to frequency, because the frequency needs to be converted into the digital mode. Once it comes to the digital technology, you have to convert that frequency into what is known as and on circuit frequency divider. The frequency is to be divided suitably for this application. It goes to the display format, power supply, and some of the main components, some of the main transformation issues, some of the main blocks like the signal conditioning, the voltage to digital conversion, the additional, the adder, the multiplier, etc., have been built into what is known as ASIC, application specific integrated circuit. So this is a microprocessor or a microcontroller or a DSP, which is built into what is known as ASIC configuration, which is nothing but a chip which does all the jobs required for the application of the metering philosophy. So this is what, and the logic is built into that, includes built-in tamper detection logics and tamper detection features. So the blue line here in the diagram is nothing but your ASIC, energy measurement ASIC. You have here the voltage signal, the voltage sensor, signal is fed here, P to N, P is phase, neutral, I phase, I neutral, current sensor, and it is fed to what is known as the current selector, which selects the current actually depending upon the load, and it goes to the energy calculation unit. There's a tamper detection logic mechanism which is written in the ASIC itself. The logic is given by the user, and you have the block diagram where the single phase static energy meter on a digital network, on a digital platform is made use of for this particular application. And it will go to the impulse counter or the LCD, whatever it is. It has two LEDs. One is the reverse polarity LED. The other is earth fault LED, which will indicate when there is a fault in the earth or when you are consuming power with earth as the neutral. So this is another way of fraud and other things, which is not in the scope of my discussion actually. Probably it can be discussed later on. So the reverse polarity is, the polarity is reversed, when you are trying to reverse the terminals. So this will indicate and then you can get the information. Okay. What are the main events and functions? Basic features of smart meter are electrical energy measurement, communication, integrated load limiting switch. Load limiting switch is what? A switch which will switch on and switch off the loads as per the requirement, which is under the clause 2 of Indian Standard Specification 15884. In fact, this is the specification, for the switch actually. And for the smart meter, there is a specification, that is IS 16444 2017 version. Okay. The tamper event detection, recording, and reporting is also most important. The power event alarm, such as the last gas, that is loss of power supply. First breathe, power on. So remote firmware upgradation is done on demand reading and also time of use, the time of the day tariff. Okay. Smart meters are nothing but the meters, electronic meters with intelligence built into them that perform their major functional requirements. So registration of electricity consumed and electricity consumed generated locally or import of export of power from a renewable source such as a rooftop solar photovoltaic cell is also possible to be read. So this philosophy is more prevalent today in most of the utilities as they are switching over to the mechanism known as net metering philosophy. So interconnection to premise-based network like home area network and devices, example, distributed generation appliances, okay, allow this meter reading both locally and remotely, either on demand using a bidirectional communication protocol. So remote limitation of the throughput through the meter, in the extreme cases, cutting the electricity power supply to the customer. Ability to read on premises or nearby commodity meters, example, water meter, gas, whatever it is. Power outage, tamper detection, voltage measurement, and time-stamped load profiling. Time-stamped load profiling means it will issue a profile, load profile of the usage pattern for the 24 hours. And also it will alert you where the high loads are there. Okay. So this is the block diagram of a typical smart meter. This is the conventional energy meter. Residential, industrial customer, energy meter, manual collection of data, manual billing. Okay. Smart meter, residential or industrial customer, smart meter, communication protocol, gateway, communication, database. So this is how it is done actually. So smart meter system will have these things actually. So this is how the architecture of a FBD approach, as I told you, functional block diagram. Okay. So this is taken from a GTM Research Department of Energy. This is a typical smart meter. What makes a meter a smart meter? Because it is like this: monitors and records, energy usage, quality of power, data storage logs, aggregate storage of mechanical data, multiple communication portfolio, protocols, and IP addressable protocols, programmable firmwares, and also notification of alarm in the event of fraud. Infrastructure. So like this, this is nothing but, a head-end system. A head-end system is a server actually. That the meter data is given to the head-end system actually. There's a firewall which protects the security. There's a collector which collects the data. And this is a WAN, wide area network. And this is a NAN, the neighbor area network. The meter is coming at the end actually, where HAN is used. That means to say home area, neighbor area, the wide area, all are used actually in the communication protocol building mechanism with which it is possible. So here it is actually a demilitarized zone. Demilitarized zone is a zone where the license is not required for the communication system. Okay. Demilitarized. It is not military application. Okay. So here, the DSO stands for, the distribution system operator, who is responsible for the distribution management. And of course, the data is totally collected, from one system to the other system in a blueprint mechanism, which will work on this hierarchy. We have to understand how the smart meter works actually, because we know the working principle of a digital meter. So how does smart meter will work? Smart meters, they measure energy consumption, energy production, and provides information on power quality. So electricity, heat, cold, gas, water, all can be measured. So, okay, the data is transferred via a PLC or a GPRS or a 3G platform or a radio wave to the smart metering system. Okay, the data is collected at the head end system, HES, collected at the head end system, and further processed in the meter data management system, MDMS. This is software. We will talk more about it, don't worry. Okay, so the data is forwarded into further IT systems. Example, customer information system is an IT system, CIS. Distribution management system is an IT system, DMS. Okay, EMS, energy management system, is a IT system. Okay, fine. So metering data is used for billing and customer services to provide very accurate rather than estimated bill, and also consumer, the customer consumption records. Utilities receive regular updates on the status of electricity network and power quality reports. So the end consumer receives bills based on the actual consumption of energy. So they're able to follow their individual consumptional pattern through a portal or in-home display. So this is a very important thing for the working of the smart meter. So as you know, energy meters are classified into different categories: prepaid meter, maybe mechanical meter, analog digital meters, three-phase, single-phase meters, mechanical meters, electromechanical meters, microcontroller-based meters, and smart. This is the latest one actually. So we are talking of wireless meter. That is the smart meter actually. What is a wireless meter? A wireless meter is nothing but a measuring instrument of power or electrical energy, and to monitor using wireless communication. Wireless communication is a radio frequency communication. So wireless communication modules, or maybe GSM module, or maybe Wi-Fi module, or maybe any other module which will have an impact on this actually. Okay, so these wireless meters eliminate manpower for metering, billing the customer's electricity consumption. Okay, okay, are you listening, sir? Hello, hello.
Yes, sir.
Okay. So this is how
Yes, sir.
a laboratory model of the smart meter is built actually. You can see here a laboratory model in the sense, how this particular thing is conceived actually. As you can see, it has the measuring circuit, the communication module, and it has, a load testing system, and it has an Ethernet cable, to connect the system. And it is also having the peripherals, for testing the meter. This is how it is conceived in the laboratory. So it has in the laboratory, probably, even in bulk also, a microcontroller based wireless energy meter. It uses, 8051 microcontroller. It's used for controlling the entire system. So this microcontroller based wireless energy meter, it consists of major components or blocks such as, MUSI, relays, loads, electricity consumption meter, LCD display, power supply, and GSM modem, connectors, and relay drivers. So these are all the main constituents of a typical smart meter. So this is how it is worked, on a microcontroller based wireless energy meter block diagram. This is taken from edgefixkits.com. If you go to this particular what we call site, you will get more information. This is a transformer, rectifier, regulator. This is a display. This is a microcontroller, 8051 series, or even better than that actually. Okay, so it has a driver here. It is a Ethernet cable connector. So here you have the ASM keyword, which allows you to embedded assembly language system with a C code. It's a load system. It's a switch on off relay. So this is how the smart meter is conceived in the mechanism. Okay. The power supply block is a block in an electrical circuit, electronic circuit, which is used to provide, required power to the microcontroller. Generally, this power supply block consists of, a step-down transformer, a bridge rectifier, an IC regulator, 7805 normally. So this is required, 5 volts DC power supply given to the microcontroller. So the block consists of main block of the entire circuit as it is programmed to the control all components to perform the desired operation. Microcontroller 8051 family is one of the best families known today. Is used actually, okay, using KEIL software. This is KEIL software we call. This is the software used for assembly language system. So energy meter interface with the microcontroller using interfacing device, middleware device, namely opto isolator, which isolates the electrical circuit. The communication modem interfaced with the and controller using an interfacing device like the MAX 232 or DB9 connector. Okay. Relays interface with the microcontroller using a relay driver, right? So it has a GSM module, a wireless electricity consumption meter. So it registers mobile number, can only have an access to the authority with which it is possible. So another thing about the microcontroller, which uses the programming with a model, particularly a GSM modem and also a display on the LCD system. So the GSM modem with a SIM sends a message, a SIM card sends a message to the RMP, registered mobile user. Okay, RMN, registered mobile number, at regular intervals. User can check electricity bill on registered mobile itself. It reduces manpower for electricity billing to all, and also wireless meter system facilitates user to check electricity bill over regular intervals based on requirement. So by using the microcontroller based wireless energy meter, we can check and pay our electricity bills online from anywhere. Even we can get reminded about the bill not paid through SMS so that we can pay bills and avoid that disconnection of the supply. So standard facilities in the smart meter are non-volatile data storage, okay, process signal from the utility. It transmits consumption of information. It interfaces with the smart appliances for collecting the data consumption. And also it is having a bidirectional relay mechanism with which it is bipolar relay mechanism with which it is possible to connect and disconnect the system. It has to be integrated into what is known as AMI module, which I am going to talk to you more about it actually as we proceed further. Okay. So this is how the customer service is in the communication system is improved actually. In fact, customer driven operation, like extending automation, mobile workforce, here is the electricity network actually. It is the customer service management system, network operation. You have the terminal, the customer, the contactor, whoever is the supplier. This is how the communication system is made more accountable in the integrated mechanism. So this is the legacy system, old traditional system. Consumer, meter, utility. Consumer consumes. He cannot communicate. Electricity meter, one-way communication. So today you have the consumer, meter, it goes to the LAN network, local area, goes to the wide area, goes to the meter data management system, goes to the utility. Here you have the home management system, smart meter on a AMI module, advanced metering infrastructure, which has component like communication, protocol of communication, meter, integrated together will form AMI. And it goes to MDMS. So MDMS is nothing but your meter data management. Through HES it goes. That is, the HES is nothing but the head-end system, and it goes to the utility. So you please understand, smart meter is not a simple product. It is a system. I'm going to talk more about it as it comes. Probably you will understand. What is actually the advanced metering infrastructure? It consists. It can answer to the requirement of demand response, the OD tariff, load control mechanism, load curtailment beyond sanction limit, tamper detection data analysis, problem of identification of the network mechanism. It reduces the ATC losses, the aggregated technical commercial losses, auditing of energy, Energy management tool gives you the billing efficiency accurately. So this is nothing but your OLTP. It is not online tap changer. It is online transaction processing. Okay. Here it is the meter data, asset management. It is actually, the billing, sales and billing, that is the marketing structure, accounts payments, real-time pricing, and here the portfolio management. And the entire networking is done on a real-time domain with a link, advanced metering infrastructure. So advanced metering infrastructure is nothing but combination of meter and also the communication with different modules. Like, it collects consumptional data, it relays demand signal, it involves interfaces and high-speed communication facility for communication between the meter data hub, and OLTP. So you saw what is the OLTP. OLTP is nothing but your online transaction process. Okay, so this is your advanced metering infrastructure. As you can see here, this is the mapping of asset mapping. This is meter data management system. Here it is the billing application. This is meter data acquisition system. It acquires the data. Here, it is the peak load management. Here the interface, voice, and also this is nothing but web portal. Here you have the smart meter, DTMU, distribution transformer metering unit, and smart meter. This is how the advanced metering infrastructure, AMI, consists of these things actually. AMI is a total infrastructure, not only meter, but communication and also protocoling. Everything is done on one platform. So that is how it is known as a system revolutionary thing actually. So this is how the conventional meter will do. Only it customer operation, that just it bills, that's all, nothing else. Grid operation, no. Work and asset management, no. Smart meter, it bills. Usage data, reading and also ability to manually read, remote disconnection and connection, bidirectional communication, visual display, meter setting configuration, tamper detection data, prepayment option, time of use, measurement of active, reactive, apparent energy, etc. Everything on one particular domain, on one particular platform. So we will now understand what is smart metering system. In fact, the smartness comes from the entire system component and not just one or two components. Hence, it has to be seen, integrated holistically, and designed and implemented keeping end-to-end system approach, E, and not the product approach. Smart meter, don't confuse smart meter as a product. Smart metering is a system. I am repeating that. So you can see here array of meters connected in a mesh network actually, smart meters. And this is the communication infrastructure, network 1, network 2, network N. Here you have all these, connected into a hub actually. So this is metering hub we call. This is the head-end system. Head-end system, I will tell you what it does, etc. in next slide actually. Okay. So this is the customer interface, nothing but your IT mechanism. This is the utility management structure. So you can just see here. So data reading, data transportation, data acquisition and control, and consumer engagement and data analytics. So this is how the data management system in a smart meter is done actually. This is how the whole activity of smart metering is done. You can one by one you can see. There are 6 slides actually which will explain smart metering. What is actually a smart meter? Particularly, the smart meter will conform to Indian standard specification 16444 or IEC 62056. It gives you all information. Probably this can be given, as a course material also. Okay. It is an AC static watt-hour meter with time of use register, internal connect and disconnect mechanism with a bidirectional communication facility. And it is designed to measure flow, forward, import, backward, export of power, reverse power, to store and communicate the same along with other parameters defined in the standard. Which standard? IES 16444. So it shall be remotely accessed for collecting the data events, programming for select parameters. Key parameters should be taught as per the drivers of the utility. It would be parameters logged in meter, tamper immunity logging, etc. Next, we will see what is communication. Communication infrastructure is nothing but the network, is a backbone of the smart metering system, advanced metering infrastructure. So this needs to be seen with reference to the availability of terrain and addressing multiple applications. So one is the reliability, scalability, security, and multiple applications like, the distribution automation, etc. These are all the main things. Actually, I am now talking to you. Smart metering system comprises of these things: meter, communication, head-end system, MDMS, customer interface, performance parameter. So we will see now what is head-end system. Head-end system acts as an acquisition system which stores data of smart meters, regular push, scheduled read, etc. So it should be decided based upon the communication network, robustness, scalability to accommodate present as well as future requirements. So utility shall be able to read, control, upgrade the smart meters through HES via proper security mechanism. So what is MDM, Meter Data Management System? MDM provides utility-specific business logic to automate and streamline the complex billing and data analytics process. So the critical role of MDM system is to process the granular interval meter data at large volumes very quickly. It evaluates the quality of the data and generate estimates where errors and gaps exist. So this also delivers the data in the appropriate format to other utility systems. So there should be provision to do the customization by the user on validation, editing, and estimation, VEE, in the data science on the AMI data. So it performs management for the vast quantities of data to validate, to clean, to process before making it available for the billing. Okay, so head-end meter data management system is combination of total software system. Head-end system is nothing but your software and hardware system. As you can see here, the smart metering, smart grid, is nothing but combination of these convergent technologies, as I told you in the beginning. What is customer interface? This is IT. The smart metering system is a distributed intelligent system. Therefore, the requirement of CI is very critical. It should be compatible to the communication infrastructure and smart meter. So CI can be a mobile device, a tablet, an iPhone, whatever it is, a special hardware which have the graphical display, easy to understand, and provide audible visual alarm in case of any message from the utility. So performance parameter to facilitate highly accurate, timely availability of data and alerts from the AMI, that is advanced metering infrastructure, which I discussed already. So there is a need to define performance parameters other than the features and functionality. So this will ensure a total communication network, so which will help utility in making several decisions in the distribution segment. So the performance level of advanced metering infrastructure system for a daily meter reading, daily meter alert, alarm, on demand, and regular data availability, etc. So there should be a clear spelled out of what has been agreed upon between the communication technology provider, that is, what we call the power supply supplier, or we can call it as the service provider, and the distribution company as part as SLA, that is service level agreement. So this is how the smart meter system will work into the communication module, will work into the smart meter module with combination of smart meter, communication infrastructure, head-end system, meter data management, customer interface, performance parameters. So this is how the smart meter and its real-time smartness is coming into picture in the demand management system, daily load profile system, accessibility, consumer applications, as you can see. And you can tailor make any of the meter to fit into this. Maybe a complex meter, like the industry meter, which is a very precise meter of 0.2 accuracy, whereas the domestic meters are 1% accuracy. So all these things could be interfaced into what is known as smart features. Here, as you can see here, the yellow ones are nothing but smart features, whereas the blue ones are nothing but the traditional features. So how the smart feature outsmarts the important features, you can see here. Okay. So we probably think I am overstepping the time. It's almost 3:20. We can just conclude some of these whatever we have discussed here, so that it becomes a very important message for us actually to understand. So the key message here is act on the root cause of losses, use cost-effective end-to-end system solution suitable for our conditions. We have to share the experiences of successful implementation program by various distribution company, use the best practical example, and consider outsourcing, billing, metering, collection services wherever is appropriate. So procurement should be based on quality, cost, and assessing the capability. So before adopting a new technology, address issues with people and process. Create an organizational effective revenue management system. Create effective engineering protocol cell for monitoring, selecting the right technology to solve the right problem, and provide necessary training and exposure. Launch a mass communication campaign against power theft. That is the most important thing. So energy meter being a crystal eye for consumer and utility, its quality, reliability shall be beyond doubt. So product quality, reliability needs to be assessed as per the respective standards, national and international, and required improvement need to be addressed and incorporated. So modernization, innovation in digital platform, particularly static energy meter, smart energy meter, has given tremendous boost for its use by utility company at present and will further grow in future due to the gain in the advancement of technology. So that is all for the day. And I think I thank you once again for the opportunity given here to make this particular presentation on the innovation challenges in smart metering system. And this will definitely provide a platform for you to understand as an introductory thing. Lot things are to be discussed here. And this is only a beginning as far as my knowledge goes in the philosophy of smart metering. So I thank the organizers once again. If there is any question, I would like to discuss with you and answer as far as possible with a short span of time. So over to Professor Pankaj Sharma.
Thank you so much, sir. That was really a very wonderful, fabulous lecture from your side. We were very enjoying your lecture. Dear participants, dear students, 2 minutes for question and answer session. If you have any kind of query, you can ask. Sir,
I'm sorry, I have overstepped the timing because the presentation is very lengthy. I have condensed it, although but still, still, I have taught